Hello. Hi guys. I hope all of you are doing well. So I welcome you all to yet another video in this Databricks playlist, and in this particular video we are going to talk about change data capture, and we also call that particular thing as CDC. We are also going to see what exactly SCD is, that is slowly changing dimensions, and how many type of SCDs are there. So in this particular playlist, we have already talked about multiple concepts of Spark, right from the basic till the advanced topics of Spark, like how we can add a new column, how we can rename a new column, how we can perform join operations, group by operations, how we can handle null values, how we can work with JSON file formats, nested JSON file formats, as well as we have also seen the different concepts of data engineering, like what exactly connectors are, right? What is the difference between batch and streaming data? What is procedural and declarative programming, and much more concepts. So if you're someone who is trying to learn Spark from the scratch, or someone who just wants to understand the advanced concept of Spark, this particular playlist can be helpful for you guys. So with that said, let's get started with this particular video, and let's get straight into the system. So the agenda for today will be to understand what is change data capture, that is CDC. So change data capture is a data integration pattern that captures changes made in the data in the source system, such as inserts, updates and deletes. So earlier in the previous video itself, we have talked about the change in schema, right? That if the schema of the table changes, how we can capture it and how we can manage it. In this particular video, we are going to talk about if the data inside the table changes. So how we are going to capture that data, that okay, this data has been changed, and how we will be able to manage that particular change. Okay. So in change data capture, what all things are what all things or what all changes are captured. So operations like inserts, updates and deletes are captured. These changes, represented as a list, are commonly referred to as a CDC feed. So the changes, whatever these changes will be done, like this, using these inserts, updates and deletes, right? These changes will be represented as a list, and that list is usually called as a CDC feed, that is change data capture feed. You can process your data much faster if you operate on a CDC feed instead of reading the entire source data set, right? Obviously, if we want to process our data, right? So let's suppose we are having hundreds of rows, right? Let's say this is my table, right? We have hundreds of rows present in this particular table, and there are only a few rows where the data got changed, and for the rest of the rows the data remain unchanged, right? So one of the process is that if we want to reprocess the data, right, and if we don't have any kind of CDC feed captured, right, if we don't have any kind of CDC feed, we will not be able to know that okay, these are the rows that got changed, right? So we will have to reprocess all of the rows again. But if we are having this CDC feed enabled, or we have this CDC field which is capturing the change, so we will get to know that okay, only these are the rows which got changed, rest of the data remain unchanged. So we will only reprocess this small chunk of data again, right? So this reprocessing thing, right, will be much more optimized, much more faster as compared to reprocessing the whole data again. Cool. So that's what it's saying, that you can process your data much faster if you operate on a CDC feed instead of reading the entire source data set. Then transactional databases such as SQL servers, MySQL and Oracle generate CDC feed. Delta tables generate their own CDC feed, a feed known as change data feed, that is CDF. So Delta tables will also generate their CDC feed, which will be more or less similar to CDC itself, but they have renamed that CDC to CDF, that is change data feed. That's it. Now in the following diagram shows that when a row in a source table that contains employee data is updated, it generates a new set of rows in the CDC feed that contains only the change. Okay. Here if you will see, so in ID number 5, right? So we are having two data, not I would say two data, two tables. The first table is of January 1st, 2024, where we have these rows of data, right? ID, name, role and country, and we have the required data present in it. Then we have the second table of 2nd January 2024. Again, the schema of the table remains same. It has ID, name, role and country column, right? But if you closely look at the ID 5, right? If you will closely look at ID 5, so here all of the things, right, from ID, name and country remains the same, but the role of ID 5 has been updated, or it has been, I would say, changed, right? So what CDC feed will do, that it will capture this particular change. Okay, CDC feed has captured this particular change and it has created a, you can say, separate row or a separate table for that particular change along with some other metadata. Okay, so if I scroll up a bit, so here you can see each row of the CDC feed typically contains additional metadata, including the operations such as update and a column that can be used to deterministically order each row in the CDC feed so that you can handle out of order updates. For example, the sequence number column in the following diagram determines the row order in the CDC feed. Okay, so here if you will now look at the table, or I can say the CDC feed. So this part of the CDC feed is the metadata, which will help the CDC feed to understand what was the operation that was performed, right? As well as the sequence number. So this sequence number will determine that this will be the sequence in which the updates, or you can say the operations, will be performed. Okay, so moving forward, when we will be seeing this particular thing practically, in that case you will automatically, or you will better understand the use of this sequence number. Okay, now talking about this particular table, the change data feed table. So here you can see we are having ID, name and role as the root table. From root table we have got these columns, and the metadata, that is operation and sequence number, has been added to the table, which can, or which will help our change data feed to get the required information. Cool. So let's move forward. Then processing a change data feed. Keep only the latest data versus keep historical versions of data, right? So if the data has been changed, we will have two options, right? The first option can be that we can overwrite the older data with the newest data, or the most up-to-date data. We can overwrite it. Means in this particular case we will not have any copy of the previous version. We will not be able to roll back, or we will not be able to create a kind of lineage that, okay, where this exactly, that like in what all places the changes were made and how we ended up to this particular version of data, right? We will only have one single version of the data, and that data will be the latest the latest version of the data. The second option can be that we keep the track of the changes, that we have the previous versions of the data as well as we also have the latest version of the data. Means, let's say if Chris role or ID5 role has been changed from owner to manager, in keeping the historical data version, that we also called as SCD type 2, that is slowly changing dimension type 2. So in SCD2 we will have a track that, okay, Chris's earlier role was owner, but later on it was changed to manager. So this is only possible when we have both of the versions of the data. Okay. So the processing of the changed data feed is known as slowly changing dimensions, that is SCD. When you process a CDC feed, you have a choice to make. So do you keep only the latest data, that is overwriting existing data, right? This is also known as SCD type 1. So if we are keeping only the latest version of the data, or you can say in another word, that we are overwriting the data, that whenever the new data or any update is made to any of the row, we are overwriting that particular thing. That's it. We are not keeping any track of the previous version. That is called as SCD type 1. Or do you keep a history of changes to the data? Okay, like this is the second option. Or do you keep a history of changes to the data? This is known as SCD type 2. Okay, as I already told you, that if you are creating the history, or if you are, I would say, keeping the history of the data, that particular scenario will be termed as SCD2, that is slowly changing dimension type 2. So SCD type 1 processing involves overwriting old data with the new data whenever a change occurs. Okay, this means that no history of the changes is kept, only the latest version of the data is available. It's a straightforward approach and is often used when the history of changes isn't important, such as correcting errors or updating non-crucial fields such as customer email addresses. Okay, so SCD type 1 involves overwriting the old data, right? This means that the history of the changes will not be kept. The version of the data is only the latest version, because we are not obviously not keeping any versioning, any track of changes. So there won't be any version. There will be only one version, that will be the latest version of the data. This is a straightforward approach, right? It's not that complex, because we just have to overwrite the new data with the older data. It is often used for history. History of changes isn't important. Okay. Okay. So it is used when keeping the track of the change is not that important. And when these things can happen, firstly, let's suppose we are having any error that we have to correct. So if it is an error, obviously we will not be keeping a track of that particular change, that okay, this was the error and I resolved this error. You cannot, but ultimately it's not going to affect a business decision. Ultimately, when we are having, or why we are doing all these stuffs, right? Why we are dealing with these volumes of data, right? Why we are managing these data, raw data, then we are transforming it to some kind of let's suppose silver layer data, then gold layer data, right? Then we are doing some kind of analytics at the top of the data. So the agenda of doing all these things is to make a good, or you can say the best business decision possible. That is the most critical agenda of handling all these volumes of data, that we get the most accurate result of our analytics, right? And with that particular analytics, we can make a good, or you can say the best business decision that is possible to be made, right? So if there are some errors that we are dealing with, so it does not make any kind of sense to keep a track of those errors, right? As well as if we are updating any non-crucial field of the customer. So let's suppose we are having a customer ID, or you can say a customer table, right? Where customer wants to update his or her email ID. So in that particular case, we will not keep a track that okay, this was the customer's previous email ID, right? And now this is the customer's new email ID, because as already said, that this particular thing or this particular analytics is not going to make any kind of business related decision to me. It's not going to give any business insight to me, right? That okay, let's suppose earlier the customer's email ID was vishal@gmail.com. Now it has been changed to vishal2@gmail.com. Hardly matters for any business, right? until unless I am the customer of that particular business, right? If I am not a customer of that particular business, then obviously it makes an impact on the business, and that's what exactly the business will track, that if I am an active customer or I am not an active customer, right? I again, like keeping a track of the status is, you can say, is a SCD type 2 kind of decision that we will make, that okay, if this particular customer was previously a free customer, let's suppose, now he has been converted to a premium customer. Now let's say he has now been again withdrawn the premium thing or his subscription, and now he is again a free customer. So these, keeping the track of these things can be a good business insight, right? And helping out, figuring out that okay, why the customer has not updated his or not renewed his subscription and all those stuffs. These things can help in taking the business decision, and obviously these things will be historically tracked. Talking about the SCD type 2, so processing maintains a historical record of the data changes by creating additional records to capture different versions of the data over time. Okay, so SCD type 2 will maintain the record, and like capturing these changes and records and maintaining the different versions will need some kind of additional records to be like to be inserted in the table, as well as some additional columns will also get inserted in the table. Each version of the data is timestamped and tagged with metadata that allows users to trace when a change occurred. Okay, so each version of the data will be timestamped, like at which particular point of time that particular data was, you can say, first of all inserted, right? Then second timestamp, let's suppose if the data has been updated, so you can keep a track of the time again, that okay, at this particular date that the data got updated, and tagged with some other metadata that will allow us to track the change that has occurred. This is helpful when it's important to track the evolution of the data, such as tracking customers' address changes over time for analysis purpose. Okay, so now you can see that maybe the customer address can be a column or can be a field that can be helpful for my business insight, right? That at maybe which point of time of the year, or even you can say even the day, right? That okay, let's suppose from 9 a.m. to maybe 5 p.m. the customer remains at, let's suppose, the Gurgaon location. It means he is working from office, right? Now from, let's suppose, 5 p.m. to later on at day next day till 9 a.m. he remains at some different place, right? Means he is at home, right? So you can basically track a habit of the customer, right? In that particular case, if you're tracking his location maybe 24/7, like these social media apps, right from Instagram, Facebook, till the food delivery apps, Swiggy, Zomato. So if you have given them the permission to track your location, they are tracking your location on you can say on a streaming level, like they are tracking your location on a 24/7 basis, that at what period of time you are at which location, so that they don't only deliver you the food, they are also tracking, you can say, keeping a track. I won't say tracking, they are keeping a track of your habits and your, you can say, your work day-to-day routine also. Okay, so whenever you are giving those permissions to any of the applications, you have to keep in mind that okay, are these permissions required to do those things or not? Okay, sometimes even applications like some you can say investment applications, right? They also need your location. So obviously that particular thing is not required. Maybe if you say that if Zomato is asking for the location, or maybe Ola or Uber is asking for your location, you can say that okay, that's mandatory, right? If they are not tracking your location, so obviously how they will be able to figure out that okay, where exactly your address is, right? So that particular thing, and that too also you can give the permission that okay, only when using the app you can only track my like you will be able to track the location, else you will not be able to track the location if I am not using your app. This is also an option that is there. So coming back to the point, right? Coming back to the point. So if you are tracking the customer's address, that particular thing can be um, a feature, or you can say a good analytics thing that can be helpful for taking my business decision. Talking about the SCD type 2, so here you can see in the table that we were having above, right? So the Chris was the person whose data got updated, right? So here in SCD type 2 table, you will be able to see we are having rest of the columns, or sorry, rest of the rows as similar, but here we are having two entries of Chris, right? Having both of the roles, the version 1 role and the version 2 role. Okay, we are, each row is now time stamped. So here if you will look closely, so the time of till here, if I talk about the data till here, it was from 1st of January 2024, right? 1st of January 2024. This update was made on 2nd of January 2024, correct? So here now you will see that the updated row, the updated row is now time stamped at this particular point of time, right? And when this particular thing got ended, like this row got ended, was on 1st of January 2024, right? It means an update operation has been performed, and now when we will be creating maybe a view for this particular table, so that our maybe users or maybe some other team can view, we will not be showing them both of the rows. Okay, you need to keep in mind that even though in SCD type 2 we are keeping both of the rows, but when we will be displaying that this particular table, we will not be displaying them first of all these columns, right? We will not be displaying them these columns, and we will not even display them this particular row. Okay, the table that will be displayed to them will be only these things that I am marking in the dark. Sorry, not even this. It will be only this much. Okay, these four rows and this fifth row. Okay, with the role updated to manager. Cool. So now let's move forward, and we will now see the type SCD type 1 and SCD type 2 processing in our Lakeflow Spark declarative pipeline. Okay, so examples of SCD type 1 and type 2 processing with Lakeflow Spark declarative pipeline. The examples in this section shows you how to use SCD type 1 and type 2. So the first step will be to prepare a sample data. Okay, so in this example, we will generate a sample CDC feed. First, create a notebook and paste the following code into it. Update the variables at the beginning of the code block to create a catalog or a schema where you have the permission to create table and views. This code will look something like this. Okay. So we will start doing whatever things this particular documentation is asking us to do. Okay, so first we have to create a new notebook and we have to paste the code. So I can log into my account. I will need my Gmail. It's 866 4UU. Create a new notebook and paste a code into it. Okay, so we can paste this code, I guess, anywhere. So what we will do is let's go to recents. We will go to our life notebook. So I'm pasting this code here itself so that you guys can also have the code in the notebook. I will be sharing this particular notebook to you, right? So let me scroll down to a blank cell. Down. Okay, so let me first of all create a markdown cell. Here let me write as change data capture, also known as CDC. Okay, I'll run this cell. Then I will come back here, and here I'll be copying this code and I will paste it to this cell. Now what we have to do is we have to update our catalog name and schema name. So we are very well aware about the fact that our catalog name is workspace and our schema, we can keep our schema name as, or you can say we can keep use the default schema. We have multiple schemas, so we can use default schema in this particular case. Let the table name be employees underscore CDF itself. If we want, we can change, right? Now what we have done is we have created a function, write employee CDF to delta. Okay, so what this function will be doing, it will be writing this table to the delta table. Okay, so here you can see the data, right? We are having one Alex, chef, France, here this insert and one. So here if you will look at the schema, so the schema is something like ID is equals to 1, name is equals to Alex, role is equals to chef, country is equals to France, operation is equals to insert, and sequence number of this particular thing is 1. Okay, then we have same for Jessica, Mikhail, Gary and Chris. So if you will look closely here, so for Chris and Pat we are having some operations, like for Chris we have from insert we have to update, right? And then we are for Pat we are having delete and insert operation along with the sequence number. So just keep a track of this sequence number at the last. Okay, this will give you a very surprising result at the end, so just keep a track of it. Then we have our columns, we have defined basically the schema. Then df dot spark dot create data frame, and we are passing the data and the column. Then df dot write dot format is delta, mode will be overwrite. Then save as table, it will be nothing but catalog dot schema dot table name, and we are calling this function at the bottom. That's it. This is what the whole code is all about. Now let me run this particular cell. So it will take a few seconds to run. And I will do what? I will open the catalog in a new directory. Let me open this catalog in a new directory. Okay, so now we can see that the piece of code, it has run successfully. Okay, it has finished successfully. Now let's go to Explorer, workspace, default, and inside this default I should have the employees underscore CDF table. Okay, so you can see right here that we are having the table. If I want to see the sample data, I can just click on select compute. I will have to attach the compute and start. So this compute is our SQL warehouse compute, right? And this compute that we usually attach is the Spark run Databricks. Sorry. This compute is usually the Databricks runtime compute, which is having the Spark runtime inside it. So here again you can see the data now has been inserted into a tabular format. All these things, all these 4 rows are basically the single rows. This row, here we will be performing some operation. We will be doing the insert operation, and then we will be doing the update operation, right? And here you can see the insert and delete operation. Correct. Now let's move at the bottom, scroll bottom. You can preview this data using the SQL command. This particular thing, obviously the same thing that we have done, right? Either we can view the data from the catalog itself, or we can run the SQL query also. So it will be nothing but workspace dot default dot employees underscore CDF. Okay, so we are getting the same data here also. Now step 2. Step 2 will be what? Use SCD type 1 to keep only the latest data. Okay, so we recommend using the auto CDC API in Lakeflow Spark declarative pipeline to process a change data feed into the SCD type 1 table. So we can create a new notebook, paste the following code into it, and create and connect to a pipeline. Okay, the employees underscore CDF function creates the table we just created above as the stream, because the create auto CDC flow API which you will use for the change data capture processing expects a stream of changes as input. Okay, So we are going to use the create auto CDC flow. Sorry, not this flow. Uh, where did it go? Okay, yeah. We will be using this create auto CDC flow API itself, right, to capture the change. And this create auto CDC flow expects a streaming data, right? It will not work on a, you can say, on a batch kind of data. We all like this particular API expects that the data will be in a streaming form, and it will automatically detect the change, and it will capture the change in the data in that particular stream. Okay, you wrap it with a decorator that will be dp dot temporary view, because you don't want to materialize this stream into a table. Okay, so we will be creating a temporary view out of this particular uh, out of the stream, basically, of, like, we are having a delta table. What we are doing is that we are changing that particular table into a kind of stream. Okay, when you will look at the code, you will get to understand it, right? I will be explaining that particular thing also. Okay, why? Because this create auto CDC flow API expects that we are getting a stream of changes as an input when it's trying to capture the CDC, or trying to create basically the CDC feed. Okay, then you use dp dot create underscore target table to create a streaming table that contains the result of the processing this change feed, processing this change data feed. Okay, so obviously if we are dealing with the processing data, we are very well aware about that we have to store the data into the streaming delta table. So using this particular function, we will be creating a streaming table which will contain basically the result of the which will basically contain the result after processing the change data feed. Now finally, you use dp.create auto CDC flow to process the change data feed. Let's take a look at each argument. Okay, so we are having the target streaming table which you defined previously. Okay, then we have the source, the view over the stream of change records which you initially defined previously, which you defined previously. Then we will have keys, uh, identifies a unique row in the change data feed. Because you are using id as a unique identifier, just provide id as the only identifying column. Then sequence by the column name that specifies the logical order of CDC events in the source data. You need the sequencing to handle change events that arrive out of order. Okay, provide a sequence number as the sequencing column. Apply as deletes. Okay, because the table data contains deletion operation, you use apply as deletes to indicate when a CDC event should be treated as a delete rather than an upsert. Okay, then expected column list, so contains a list of columns that you don't want to include in the target table. For example, you will use this argument to exclude sequence number and operation, right? As I told you that in the base column we will not be having these columns. Then stored as CDC type, so indicates the SCD type you want to use. Okay, so these are nothing but these parameters that my create autoflow CDC function will be taking. So it has explained all the parameters, what all these parameters are. Okay, now as we already know that we have to create a pipeline. Okay, so what we can do is either we can create a new notebook, something like this, or we can directly create a pipeline. So how we will be able to create a pipeline? I hope you guys are now aware about it. We will have to go on new, right? And I will click on this ETL pipeline. Okay. Now I can rename this ETL pipeline to, let's suppose, CDC CDC English, let's say. Okay. So in workspace, okay, default, okay, and we will start with an empty file. We can start with maybe the SQL code, the Python code, or we can start with empty file. So I will start with empty file. Okay. So yeah, folder path is fine, language is fine. I will click on select. So now we have the my transformation.py file ready for us. Now I can come back here. I can scroll down. I can just copy and paste this whole code here in my transformation. Here I will have to again change my catalog name to workspace, schema name to default, and rest of the things I guess will remain as it is. Correct? So let's go through the code once. So what we have done from PySpark, we have imported pipelines as DP. Okay. Then from SQL.functions, we have import call, XPR, lit, and when. We have already talked about all these functions. Then from SQL.types, we have imported string type and array type. Also, we have talked about all these things in the playlist in a very detailed manner. Then we have defined all our variables, catalog, schema, employees CDF table, where our data is basically the CDF feed is available, right? Then the current table will be employees underscore current. The historical table will be employees underscore historical, right? Then we are first of all creating a stream of the table of employees underscore CDF table. We will be creating a stream of it. So how we will be able to create a stream? Spark.readStream.format, and the format is nothing but delta, and table location is this, right? So this function will create a stream out of my this employee underscore CDF table. Okay. Now the target table is create target table. Okay. So we will have to create the target table with catalog.schema dot employees underscore current name. Okay, so it will create a new table here in the this particular default schema as employees underscore current. Okay, and then the auto flow CDC will be made. So here first of all we have to pass the target. So we are very well aware about the target table is this one, employees underscore current. The source table is nothing but employees underscore CDF table. So this is the table. Here we have given the variable name, right? The keys that we is uniquely defining the rows are nothing but the ID keys. So that's exactly what we have passed, right? Sequence by, so the sequence number, right? This is the column which is having the CDC sequence, right? This is having the feed sequence basically. So we have passed that particular column, right? Apply as delete. So if the operation is as delete, we have to apply it, right? Like when the row will get deleted, when the operation will be equals to this delete. Okay, that is exactly what we have given here. Okay, then expect column underscore list means in the target column we will not be adding these two columns, that is operation and sequence number, as I already told you, because these columns are more of a metadata columns. This does not belongs to the root table that we are having, right? So we will be excluding these columns in the target table. And how the data will be captured, or you can say the CDC will be captured, it will be captured as type 1, means we will not be keeping a track of the history. We will update the whatever is the in the newest version, right? That's it. And now we can run the pipeline. So it will take a few seconds to run the code. Okay. So now the code has been successfully ran, or I would say the pipeline has been run successfully. Okay. You can see the tables, right? This is a streaming table. You can see that there is a kind of stream that is there in the table, right? And here you can see a kind of specs that has been made. So this is a kind of view. You can also see the type here. It is a view and this is a streaming table, right? So let's go ahead, and if I refresh this page, now we are able to see employees underscore current. So let me open this table. Let me go to sample data. So now here we are able to see our data without any kind of you can say versioning or any kind of history, right? We are just having the uh, we are just having the latest version of the data. But here if we will look closely, so we are having the role as owner in Chris, right? We are having the role of owner in Chris. This is because if we come back to our employees underscore CDF, if I come back to my sample data, so here you will be able to see in the sequence number, right? Role manager is having sequence number 5, and Chris owner is having a sequence number as 6. It means manager, like the role manager was given earlier and then later on it was done to owner, because in CDC feed the sequence number was 6 for name Chris and the role was owner in that particular case. The first thing, right? The second thing is, if I go back to the current employee table, right? Here you will not be able to see ID 6, that is Pat, right? We are only seeing till ID 5. Again, this is because Pat got inserted with sequence number 7, right? And the ID, or you can say ID 6 or name Pat, got deleted with sequence number 8. And for that reason, you are not able to see Pat here as a row in the target table. Okay. So now I hope you are now also guys are like you guys are now able to understand the importance of sequence number also, which we have also talked about earlier, right? So now if you want to see it, okay, for sure, okay, what I will do, let me add this code to the notebook also so that you guys have the code for it. Where is the notebook? Life. Let me scroll down. We have written a lot and lot of code in this particular playlist. Okay, so let me add the code here. So this is the pipeline code. It will be workspace, and this will be default. Now let me come back here, and we will be seeing the same thing with the select star command that we are running right now. So workspace dot default should be default, and if we run it, we will be only seeing the same thing that we are able to see here, right? So here you will see, note the out of order update for employee Chris was dropped correctly as their role is still set to owner instead of manager, right? And that's exactly what I was talking about. Okay. Now step 3, use SCD type 2 to keep historical data. Okay. Now we will be keeping, like in SCD type 2, we will be keeping the version of the data. We will be keeping the previous version as well as the second version or the updated version also. So in this example, you can create a second target table called employees underscore historical that contains a full history of changes to employees record. Add this code to your pipeline. The only difference here is that the stored as CDC type is 2 instead of 1. Okay, so here if you will look closely, so all the things are exactly the same, only this parameter for this particular thing stored as CDC type is now changed from 1 to 2. It means we are now dealing with SCD type 2. So let me come back to my pipeline and let me add this piece of code right here. Okay, and I believe nothing else. Run the pipeline too by clicking start. So I will again run the pipeline, and if I will have to come here, so here we will be having something as employees underscore historical. Okay, so now the pipeline has ran successfully for the second time also. It has completed, right? And now you can see the third table also, workspace.default.employees underscore historical has been created. Again, the type of this table is a streaming table itself. And let's get right into the catalog to see our historical table. So now if I go to employees underscore historical table, and if I go to sample data, so you will be able to see the previous versions, right? As well as the pat thing also, right? We are able to see this pat here, right? And here if you will look closely, so we are having a few extra rows, that is started at, ended at, and all these things. So why we are having these things here, right? And how we will be able to show the updated data to the users. So here in this case, what we will do is that we will create a kind of view where we will be choosing, let's suppose where ends at is having only the null value. Okay, only display those rows, and we will only display ID, name, role, and country column. Okay, so this is how we will be able to, and if you will look closely, So it will display the very same data. Here it will have the owner role of Chris, right? And it will add all these 4 rows along with the columns, right, to the view. Okay. So if we are dealing with SCD2, we will not directly display the whole table to the users or to anyone, right? We will be creating a view on top of the SCD type 2 table, and then we will be able to display that particular thing based on the condition that we will be giving in that particular view, right? Here we can give that wherever the ends at is equals to null, you can display all those rows, right? And it will display exactly the same rows that our SCD type 1 has displayed. It will display all these 4 columns along with this row of Chris. Okay, it will not display this manager one, and it will not display Pat as mechanic because the ends at is not here as null. Okay. So here we have even kept the version, right? If we want to, let's say, roll back, or if we want to just to know that, okay, from owner or to manager, it got changed to owner, right? And even Pat got what happened to Pat. So at sequence number 8, I can understand that, okay, the operation of Pat was delete, so Pat row was deleted. But here we are having the history of everything in the employees underscore historical table. Again, we can use this thing. So let me just copy and paste the code here. So I can control V. Okay, and I can paste this code also. So catalog will be workspace. Schema will be default. Okay. And again, if I run this cell, obviously we'll be able to see the same output that we have seen in the UI. Then cleaning up the resource. When done, you can clean up the resource with the following step. We can delete the pipeline, check the job and pipeline, and we can delete it. Delete the notebook and delete the containers or the tables that we are having. Okay, so we can do it later on. Now we can do the very same thing what we have done with this this function CDC create auto CDC flow function that is doing for us, right? We can do the very same thing using merge into and for each thing also. Okay, for changing the data capture. Now let's understand why we don't do it and we don't ever implement this particular thing. So Databricks provides a merge into SQL command that you can use with for each batch API to upsort rows into a delta table. Okay. This section explores how this technique can be useful for simple use case, but this method becomes increasingly complex and fragile when applied to real world scenarios. Okay. So if there is a very simple use case, we can go ahead with merge into and for each batch API if we want to use the same thing, or maybe the if you want to replicate the slowly changing dimension thing without using the function. Okay, but this method will become very complex and fragile, means it can easily break when we are dealing with the real world scenarios. If the volume of the data is too huge, or maybe the complexity of the changes is very high, in that particular case this particular way can be very complex, right? And we never use it. if we are having the simple thing, right, we can just use a function to do the same stuff why we'll be doing or implementing the naive implementation, right? So naive implementation with merge into and for each batch. So create a notebook and copy the following code to it. Change the catalog, schema and employee table variables as appropriate. The catalog and schema variable should be set to the location in Unity catalog where you can create tables. You can run the notebook. It does the following: create the target table in create table parameter, whatever create table parameter will be given. Okay, it will create the target table. Unlike create autoflow CDC, which handles these steps automatically, you have to specify the schema. So we will also have to specify the schema in this particular case. Okay. Schema. Read the change data feed as stream. Each micro batch is processed using the upsert to delta method, which runs a merge into command. Okay. So each read will be changed into a stream, because we are already know that if we want to change the data or if we want to create a CDF, in that particular case, we have to deal with the streaming thing. And each micro batch will be processed using the upsert to delta function. So here if you will see, so here you can see, right, we are using the upsert to delta function to process each micro batch, which contains the merge into SQL query, okay, which runs the merge into command, right? So if we will run this particular whole cell, we are not going to run it, right? Because obviously firstly that video has been very long, right? So we will not run it to save our time, because this thing we will never be implementing in real world scenario. So we will only just go through it quickly to understand the problem and the issues and the complexity that this particular implementation will have, and why we never implement this particular thing. Okay. So we will create a catalog, we will create a schema, we will define the tables. We have defined a function as upsert to delta function, right, where we will have a micro batch, a batch ID, and we have written a few SQL code. If you want, you can go through it. It's not that difficult. Then we are creating a table, right? We are running the create table function. We are capturing the CDC feed from the root table, and then we are writing it to our we are writing the CDC feed using the upsert to delta function. So ultimately the result will be something like this, right? Now unfortunately the result is incorrect as shown following, right? Multiple updates to the same key in the same micro batch, right? So you can see here we are having multiple updates to the same key in the same micro batch. So the first problem is that the code doesn't handle multiple update in the same key in the same micro batch. For example, you use insert to insert the employee trace and then update the role from owner to manager. This should result in one row, but here you have got two rows, right? Here we have got two rows instead of one row, right? The logic becomes more complex. Now the following code will handle that particular part, right? Now we have only one row, but here we are now seeing again the mechanic thing. So out of order update across the micro batches, right? So here what it will do, first of all, if you look closely, so here it will insert and then it will update, right? So it will handle this out of order updates across the micro batches using these commands. Then it will handle deletes using these commands, right? Then handling arriving out of order after deletes, it will use these commands. And then after that, it will create a view to give us the resulting table. So you can clearly see how much complex it has become, right? If you want, you can go ahead and read it line by line, but I would suggest not to waste too much of time on this, because we are never going to implement this particular thing into our work ever, right? So this is pretty much it for this particular video. I hope you have learned a lot of things about what CDC is, why do we need CDC, right? What is slowly changing dimension? how many types of slowly changing dimensions are there, and we have also implement the CDC part and the slowly changing dimension part practically into this particular video. So I hope you learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.